Hey guys, and happy Friday. I just want to walk you through some interesting stuff that I did today. I wouldn't say I got any of it worked out, but I'm going to glance over a bunch of things because it's kind of a cool process. And if anybody's interested, feel free to reach out. I'd like to discuss further. I'm still working on this. So basically, the general concept is I'm trying to account for topography when I'm doing vegetation assessments with drone or UAV-based NDVI imagery. So what I'm doing is I've got my high resolution ortho here. I've got a high resolution digital surface model and a hillshade. So what I want to do is classify this landscape into the topographic position based on is it a hilltop, is it a mid-slope, or is it a depression? So long story short, when I use Sega's TPI, I've been using a Gaussian weighting function and a bandwidth. I wasn't really sure how this works, and it all plays into the eventual outcome. So I wanted to kind of try to iterate through this, but I have to make that new TPI raster, and then I have to convert those to polygons and zones before I can do any kind of stats with them. So I decided to experiment with QGIS's model designer. So I built this quick little workflow. So you input a reclassified TPI, and I reclassified them into, kind of play around with the symbology and style it. So I think it matches the best how it's going to fit kind of match the surface model. So I polygonize that, and then I dissolve those polygons so that we've only got our 3 classes. And then on that, this is actually the wrong one. I'm going to so then I'm going to take, I've got some zones, which are kind of my area of interest or lease or whatever, and then a background area that's around it. I cut out like a rock pile and a few things that aren't necessarily natural. So that's where I get my zones from. And that gives me an intersection. So now I've got, within those zones, I've split them into hilltop, mid-slope, and low area. And then I'm going to run zonal stats with the NDVI data, and it's going to output this here. Then I can quickly iterate through all these different TPI iterations that I've made, with a narrow bandwidth, with a larger bandwidth, with a coarser resolution, things like that. So all you do once you've got this set up is I'm going to click my Gaussian power of 2, which isn't really relevant here, but then a bandwidth of 10 and my 2024 NDVI. I'm going to pick my least versus background normal, and I'm going to just ignore that and download data temporary layer. I'm just going to run that. Just going to quickly burn through all these, which is saves me quite a bit of time. So it's done. I'm going to move this. So now what it did was, so first it vectorized. So it made my polygon into vectors. And then I dissolved it, so I only had 3 classes. It's not styled appropriately. Then I took the amount that intersects here, and then I calculated my zonal stats. And when I look at my zonal stats, it's vectorized. So I get background lease, my topographical position value, and then the count, the mean, median, standard deviation. Then I was wondering, is there a way that I could look at this a little more efficiently? So I coded up using Replit's agent and cursor a quick little web app that lets me open these. So I'm just going to open up 3. So I opened up 3 of those zonal stats CSVs that I made. So then the first thing that we're going to do is So this is showing the NDVI distribution by the zone for the 10-meter bandwidth one. So low areas, mid-slope, hilltop. So this means that overall our low areas have a higher NDVI value than anything else, but there's a lot more variation at the hilltop. Next, at a 20-meter bandwidth, we see the same thing, same trend. And then we see here, same trend in the 30-meter. So next up, we can have a quick look at the how each one looks. So here, this is the lease hilltop and the background hilltop for each. So we can see in this case, actually, the finer resolution, we had higher values. The mid-slope was the opposite, where we had more separation at the coarser resolution. In our low areas, we see the same. So it's whatever. I don't know my way around all this data yet, but it's a good way to look at it because I'm trying to figure out, the best way to look at this stuff. Here's summary tables based on what you know. I'm mostly just playing around with Streamlit and what AI can help me do there. Now here we're looking at the process data. So I'm looking at first this 10-meter. It styled it, a little bit of styling based on the low areas is green, yellow is mid-slope, red is hilltop, and then it gives me the difference in the percent difference in mean versus the background area. So this one's negative because the median is actually higher in the background. And this one here, the mean difference. So it's, sorry, my mistake. This is the mean, and the mean on the lease is lower than background, so it's negative. The mean on the lease is higher than background, so it's +2, and the mean is higher in the background, so it's +8% different. Double check this because the median is actually opposite there. Next up, we've got some visualizations. Long story short, I didn't look at the code too carefully, but what I did do was there's this new Deepseek R1 and it's a pretty cheap reasoning model. It's only been out for a couple days. And what I did was hooked up, I got my API key there, I'll have to change. But I've got this little system prompt and some analysis. So if I hit this, it's going to send the outputs of my Streamlit data analysis to R1, and it's going to do some thinking about it. I think this is interesting because this isn't a chatbot, right? This is, I mean, I've got a chat below, but this is kind of, I've already baked the prompt in, and then I'm just handing it data. So it kind of just generates this quick little report, right? So it talks about which TPI configuration shows the largest stratification between zones. So it's saying the 30-meter shows the largest stratification because there's a wider range of NDVI values. Long story short, I'm not going to go into details here. The point is, I think this is the way that AI is going, is it shouldn't necessarily rely on the user to prompt, and everything doesn't need to be a chat. Here, we're taking some data from a CSV, we're doing some Python data analysis with it, then I'm feeding those outputs along with a system prompt into the R1 model and getting this kind of reasoning out, suggest for additional investigation. And then, we can still do this, say, which zone has the highest NDVI in general? Hilltop, mid-slope, or low area? So she's going to think. So the low area has the highest across all data sets. So it's actually using the data. It's kind of a fun little Friday project. First time that I've actually integrated this kind of data analysis into Streamlit, and it's pretty cheap. I bought $5, and I've just been playing with that one there. But we've used a few requests. It's been used to send up, so kind of fun. Be curious to know where else it would be interesting to use a Streamlit app that's looking at data and then feeding that into an LLM or ideally a reasoning model and getting a more of a structured report back out. So anyways, kind of a cool deal. I'm not going to say that that's the be all end all way to look at this. And I want to look at the code and make sure that it's looking at everything right. But for a little bit of time this afternoon on Friday, kind of a really neat way to incorporate a bunch of different concepts into something that is fairly practical.